Hi, this is my assessment 4.2 presentation summarizing my assessment 4.1 on distributed databases. I'm answering cluster 1, so I have one slide per question from question 1 to question 8. On each slide, I will explain the idea in plain terms and give the same example I use in my written submission. Question 1 is the difference between homogeneous and heterogeneous distributed databases. Homogeneous means the same database system is used everywhere. So we have the same product, same tools, same behavior, and that's easier to manage because everything works consistently. When it comes to heterogeneous distributed database systems, that actually means that different database systems exist across different sites. So this often happens after a merger. For example, one team keeps PostgreSQL, right? Or let's say a finance state decides to stay on a SQL server, and older services still run on MySQL. So to make those different systems work together, companies usually rely on three things. So we have federation for reporting, application or synchronization to keep shared data aligned, and ETL pipelines to pull everything into analytic and governance reporting. So the simple takeaway in slide 1 is homogeneous is simpler, heterogeneous is more flexible but require more integration. Moving on to slide 2. Question 2 asks what all distributed databases have in common. There are three big goals. First is transparency, meaning the system tries to hide where the data is stored. Users shouldn't have to know where the data actually is or located, whether it's in Texas or California or Europe. That is the first one. The second is distributed query processing, meaning the database spreads the work across multiple servers and tries not to move too much data across the network. The third one is correctness under load and failure, meaning even if lots of users are updating things at the same time, or if one node's failed, the result should still be correct. So a simple example is a support dashboard from my screen on the right, one logical view. We can see that one customer view, but behind the scenes, the system route to the right shared or replicas, processes in parallel, and merges results into one response. Question 3 asks for real-world example. So two examples are Google Spanner and Amazon DynamoDB. So Spanner is built for global services that still need strong consistency across regions, meaning the system tries to stay correct even when data is spread out geographically. When we talk of DynamoDB, that is an Amazon a DB and is managed distributed key value and documents database built for high throughput and low latency. So it's used in things like shopping carts, user sessions, and product data, in places where speed and scale really matter. So the main point is when global traffic grows and uptime matters, a single server becomes a bottleneck, and companies move to distributed databases because they cannot really rely on just one. So question 4 is what factors matter most when choosing a distributed database strategy? I think the biggest one are latency, availability, consistency, operational complexity, and lastly cost. So let's talk about latency. Putting replicas near users makes things actually very, very fast. But cross-region writes add coordination, which can actually slow things down. Availability, replication helps you stay online if one location actually fails, but it also creates one new issue. or create new issues like partial outages and tougher debugging. So consistency is also the key decision. Payment and inventory usually need one correct answer immediately. But things like recently viewed or recommendation can accept eventual consistency. So key value systems are often a good fit there. Finally, it makes more complex and expensive to operate distributed systems because monitoring, debugging, and changes are harder across multiple nodes. The next slide, which is question number 5, is why heterogeneous systems happen, or why organizations choose heterogeneous distributed databases. Most of the time, it's real life mergers, old legacy systems, licensing limits on even modernization. Companies rarely rebuild everything at once. So sometimes it's intentional because different workload fits different databases better. For example, a retailer might use a rational a retailer may use a relational databases for order, a Dynamo DB for cart and session, then move data into an analytics platform for reporting. So the trade-off is you get best tools for the job, but you pay for it with higher integration and governance efforts. Moving on to the next one, which talks about date rules 9 through 12 and how realistic they are. These rules basically says a distributed system should be independent of hardware, operating system, network, even the specific distributed databases. Today, rule 9 to 11 are easier because browsers, containers, and cloud services hide a lot of differences. A good example is Google Docs. It works similarly on PC and Mac because the browser is the main runtime and the app is cloud hosted. Rule 12 is the hardest. Distributed databases independence because different databases behave differently. SQL dialects, indexing behavior, transaction isolation, and drivers can force code changes when moving from PostgreSQL to SQL Server or MySQL. So in short, cross-platform apps are easier than cross-database portability. Question 7 is whether any real systems follow all rules. In practice, few, if any, production system fully meets all 12 rules because companies trade ideal transparency for performance, reliability, and the ability to observe what's happening. Spanner is a good example. It provides strong consistency, but it uses coordination mechanisms that introduce latency. Developers still need to understand those trade-offs. Also, DBM's independence is usually partial. Federation can unify basic queries, but deeper DBs features like stored procedures, indexing options, and isolation semantics are different. So most systems end up being workload specific rather than perfectly universal. The final one, question 8, is open source distributed database example. So TIDB is distributed SQL aiming for MySQL compatibility. It scales horizontally and supports high availability. So it's fit for SaaS and multi-tenant apps. VTs is a sharpening, it's a sharding and clustering layer for MySQL. It helps large MySQL environment scale without rewriting everything, and it supports operations like resharding. Gigabyte DB is distributed SQL aiming for PostgreSQL compatibility and is used for microservices that needs SQL with fault tolerance across nodes and regions. So the quick takeaway is these are common open source options depending on whether you are scaling MySQL, looking for distributed SQL, or supporting microservices. So the slide list there, this slide lists the references for all my conversation, all my presentation. So thank you. That concludes my presentation.